Hello everybody. Today we are going to discuss about conic sections. Okay, conic sections. C-O-N-I-C, conic sections. Okay, in the conic sections, we have to draw three main curves. That is, three important curves. That is ellipse. Okay, ellipse, comma, parabola, comma, hyperbola. These are the three main curves: ellipse, parabola, and hyperbola in the conic sections. Now, how to draw? Before going to this, we should know one small definition, that is eccentricity. Eccentricity. Okay. Now, the eccentricity means, it is the ratio between, it is the ratio between vertex to focus, vertex to focus, and vertex to directrix. Okay, vertex to directrix. Okay, now if f is the focus, f is focus, okay, and comma, capital V is vertex, and capital C is point on directrix, point on directrix line, directrix line. Okay, directrix means it's a line, and vertex and focus is a point. Okay, now what is C? C is point on the directrix line. Okay, then we can say CF, total CF, or I can say E is equal to eccentricity, E is equal to VF by VC, VF by VC, E is equal to VF by VC. It means CF is equal to, I can write VF plus VC. What is this CF? What is this? We'll see. Okay, now let us assume that directrix means what? Directrix means line, and C is point on a directrix line. V means it is a point. F means it is a focus. Now both focus and the directrix line are fixed, but the vertex is moving. Okay, means this vertex will decide which curve we have to draw. Now how it is moving, we'll see. Suppose there is a fixed line, directrix A, B, I am assuming. Okay, and suppose I marked a line, a point C. Okay, suppose if I draw from C a perpendicular line, and at certain distance, he will give the distance from directrix to focus, means both are fixed, this and this is fixed. Now where to draw the directrix? Suppose, now where to draw the focus, I mean vertex. Okay, if the vertex is nearer to focus, the curve will get is ellipse. Okay, the curve will get is what? Ellipse, if the vertex is nearer to focus, like this. Okay, and what is this? This is another vertex. We know that in intermediate we have studied. and this is the another directrix A dash and B dash, and this is the point C dash. So focus will be somewhere here. Now it means vertex is nearer to focus. The curve we'll get is ellipse. Okay, if the vertex is nearer to focus, the curve we'll get is what? Vertex. It means the ratio of eccentricity is less than 1 here. It means the ratio or eccentricity, we can say. Eccentricity itself is a ratio. Eccentricity is less than 1. Less than 1. I am writing here numerical number 1. It means vertex is nearer to focus. Now let us come to the next one. What happens if the vertex is center? Okay, if I'll draw a line directrix. Directrix means a line. Now if I mark a point C on the directrix line, if I draw a line C from point C such that this line is perpendicular to AB, if I mark CF at certain distance, he will give the distance C to F, means directrix to focus. He will give some distance. If I draw the vertex in between, exactly at the center of CF, the curve I will get is parabola. The curve I will get is parabola. Parabola. It means eccentricity is how much? Eccentricity is equal to 1. Eccentricity is what? Equal to 1. Means ratio is 1 by 1. VF is 1 and VC is 1. Means both are equal lengths. 1 by 1. Okay, done. Now let us come to the hyperbola. If I draw a directrix line AB, mark any point C and draw a line perpendicular to AB. Okay, and he will give the distance from directrix to focus. If the vertex is nearer to directrix, okay, the curve I will get is what? That is, I will get hyperbola. It means eccentricity is, means I am writing here hyperbola. It means eccentricity is greater than 1. Greater than, I will write here, space is not enough here. Okay, I am writing here eccentricity is more than 1. I can write here more than 1. Okay, done. So what we have learned here? We have learned that if the vertex is near to focus, the curve will get is eccentricity. The curve will get is ellipse. If the vertex is exactly center between CF, the curve will get is parabola. If the vertex is near to directrix, the curve will get is hyperbola. Okay, now let us solve the questions now. Suppose he has given a question. See here carefully. Let us read the question. Construct an ellipse by general method in which the distance between directrix to focus is 50. Means CF is equal to 50 he has given. Yes, directrix to focus CF is equal to 50 he has given, and eccentricity is 2 by 3. What is this 2 by 3? We'll see. And also draw normal and tangent to the curve. Okay, done. Now how much he has given? CF is equal to 50 mm, means 5 centimeters. What I'll do, first I'll draw a line. Okay, somewhere here I'll draw a line, that is directrix line. Yes, that is directrix line. I am drawing, that is A and B. and mark any point C on the directrix. Mark any point C on the directrix. Now from the C, draw a perpendicular line like this. Means this line should be perpendicular to AB. After that, how much he has given? CF means directrix to focus is how much? 50 mm. So I am marking 50 mm means 5 centimeters. See here. And I will mark F. Now let us come to the eccentricity. How much he has given? He has given E is equal to 2 by 3. Now what is our formula? VF by VC. Yes, VF by VC. Now see here, CF he has given. See here, CF means we can write CF is equal to, if the V is somewhere in between C and F. Okay, V is where? In between C and F. So I can write VF plus VC. Yes, if the V is in between C and F somewhere, I can write VF plus VC. I can write. It means VF, how much the ratio he has given? See, it is 2 plus 3 is equal to how much? 5. CF means 5 equal parts I have to divide here. Means VF is 2 equal parts, VC is 3 equal parts. Done. Now what I am doing is I am dividing this. CF is 5 equal parts, that is 1, 2, 3, 4 and 5, because the total 2 plus 3 is 5. Done. Now where to mark the vertex? That is our point here. So now how much he has given? VF is equal to 2 means from F to V how much? 2, that is 1 and 2. I am marking here. This is V. Now VC is 3, it means 1, 2, 3. So total 3 plus 2. Now I'll draw from here, from the vertex. So vertex is near to focus now. The curve will get is eccentricity. Now what to do is, in the next step, I have to draw from the vertex, draw a line, a perpendicular line. Next step. Okay. Now we are going to draw ellipse. Now here we know that vertex is near to focus. Okay, because he has given 2 by 3. Okay, V to F is 2 equal parts. C to V is 3 equal parts. Means CF, C to V is more. And VF is less distance. Means V is near to F. Now I come to know that it is an ellipse. Okay, done. Now next step what to do is, take a radius. See here, take a radius VF. Take a radius VF. V as center, draw the curve. Okay, draw some curve such that it should cut this vertex line and mark this is E, somewhere E. Now what to do is, from CE draw a line, join a line from CE, okay, and extend this line. This is I am extending. Okay, after that what to do is, from F, from the focus, take a 45 degrees line. Take a 45 degrees from the focus. See here, mark 45 degrees from the focus, and now join this 45 degrees and extend this line. See here carefully. What is happening is, this focus 45 degrees line and this CE is joining somewhere. I am calling as some X. I am calling this as some X and extending this line. Done. Now from X drop a perpendicular line. From X drop a perpendicular line up to this CF line. Now what is this? This is another vertex V dash. This is the another vertex V dash. I have got V and I have got V dash. It means I can draw the ellipse in between V and V dash. See here, we have already done V and V dash. Okay, we have got V dash in this manner. Now, what to do is, next step, in between V and V dash, mark any number of points. Some 1, okay, 2, okay, 3, 4, 5, okay, 6, and some points 1, 2, 3, 4, 5, 6. Need not to be equal. Okay, now next what I'll do, from 1 drop a perpendicular line up to this CE line. See here, this is CE line. Up to CE line, what I'm doing, from each and every point I'm drawing a perpendicular lines up to CE only. Now if it's this one line is touching CE, I'm calling it as 1 dash. If I draw from second point perpendicular line, then I'm calling as this is 2 dash. If I draw from third point, I'm calling as this is 3 dash. Okay, the same manner, from 4 drop a line up to C E. This C line. Now this is 4 dash, like this. From fifth point, this is 5 dash. This is 6 dash. In this manner, I have drawn a lines. Some lines, certain lines. Okay. I will extend this one perpendicular lines such that it should be neat. Okay. Done. Next what to do is, take a radius. Next step is, take a radius 1, 1 dash. Take a radius 1, 1 dash. Focus as center, cut the 1, 1 dash on both the sides. Okay, what we'll get, and I'll name this one, this is P1 and P1 dash. Okay, next what to do, take a radius 2, 2 dash, this line, and same focus as center, cut the second line, 2, 2 dash line on both the sides. Okay, now this is P2 and P2 dash, like this. Okay, next 3, 3 dash. Focus as center, cut the third line on both the sides and name them. That is P3 and P3 dash. P3 dash, like this. Next, take radius 4, 4 dash. Focus as center, cut here. This is P4 and P4 dash, like this. Okay, this is P4 and P4 dash. Okay, next, take a radius 5, 5 dash. Focus as center, cut here. Okay, this is P5 and P5 dash. Write down immediately, this is P5 and P5 dash. Next, radius how much? 6, 6 dash, see here. Next what to do? Take a radius, see here, P6 and P6 dash. Done. This is P6 and P6 dash. Join all the P points. What we'll get? We'll get ellipse. See here. In this manner, I'll get the ellipse. You have to draw with freehand. You have to draw with freehand, like this. See here, from the vertex, I am joining here. Okay, the curve we have got is, see here, I have drawn something like this. Okay, the curve is said to be ellipse. Now let us come to the normal and tangent. He said any point, draw normal and tangent at any point to the curve, just he said. So what I'll do, I'll mark point Q somewhere here. Mark Q on the curve somewhere. Now next, join Q and F directly. Just join QF. After that, to this QF line, draw the perpendicular line up to the directrix. Now what I am doing? I am taking 90 degrees. Mark 90 degrees. Done. 90 degrees to this QF. 90 degrees to QF. 90 degrees to QF. Now joining 90 degrees like this. Join QF ki 90 degrees. Now I name this one as T. Now join T and Q. The line will get is tangent T dash. Now perpendicular to the tangent is normal. We know that. This is N and N dash. So in this way we can draw ellipse. In this way we can draw the ellipse. Okay, next curve we'll see in the next video. Thank you very much.